we're putting everything all together. We've defined how to interact with variables using the keyboard and the mouse. So let's try building a simple little game. First I'll play it just so you can see how it works. And I should have checked first. Okay, so I'm using mouse X and mouse Y to move this paddle. Let's get this centered here. Okay, so okay. So basically I'm horrible at games. If I can get the paddle under the object, it will reverse its direction. So and this paddle is too small for someone as unskilled as me. So let's see, let's walk through the code and see what we've got here. So I've got an X and Y position. I've got a diameter of 20. So the X and Y position is for the ball. Okay. The diameter is the size of the ball that's bouncing around. Move X and move Y controls the speed of the ball. Gravity just lets it accelerate a bit as it falls. The score keeps track of how many strikes or how many times I hit the ball and how many times I miss the ball. And then we've got a pad W of 35. So that's how wide the paddle is. It's 35 pixels wide. Far too narrow for me, so I'm going to bump that up to 50. Okay, so we've got size 500 by 500, color mode HSB, doesn't really matter because it's black and white. Background is 0, so I only draw the background once in the setup. I've got a rect mode set to center because I want to be drawing from the center because that's how I'm drawing the paddle down at the bottom, and I'm hiding the cursor because I don't want the cursor on the screen because I'm using the cursor to move the paddle back and forth. So here we've got no stroke, fill of black with a alpha of 50. And so let me run this again just so you can see. So what I'm doing here is you can see there's a little trail on the ball. See, that's easier to hit too. And we're getting that by instead of drawing a background like we did up here, we're drawing a rectangle with a color black, a fill of black, but a 50 alpha. So it's a semi-transparent black rectangle that fills the entire screen, right? So it's centered 250, 250, and it's the full width and height of the screen. Then we set the fill to white. We draw the ellipse, X and Y, diameter, and so these are dynamic. Move Y equals move Y plus gravity, so we're just accelerating as it falls. And X equals X plus move X, Y equals Y plus move Y. So that's moving the ball around. Then we're drawing a rectangle based on mouse X, and then we're setting it at height minus 15. So again, going back, it's 10 pixels tall, but we're saying height minus 15, so we're actually drawing it offset by 10 pixels, right? So it's setting up from the height or the 500, so it's at 485. Okay, so if now let's look at some conditionals here. So if y is greater than height, I reset the x value to some random space between, and I set the y value to negative 30. So it resets it back to the top of the window. So that's the ball. So if the ball goes past the paddle, it resets it back to the top of the window, out of frame by 30 pixels. And then resets move y to 0 to reset the speed of the ball. The ball and we also set the score to score minus 1. So if I miss it, I deduct 1 point from the score, I print the line score equals, and then print line score. So it's actually printing the score. So I'm actually going to take this out of here because it will only print that when I'm missing a ball. So let's put that outside of this conditional. That should just be something that's, well, you know what? We don't need it constantly running. So what we'll do is we'll also put it here, because what this does is if it actually hits the ball. So if x, the value of x, the x position on the ball is greater than or equal to mouse x minus the pad w, so the size of the pad, so it's 50 divided by 2. So the x position minus, it's 50 divided by 2, so 25. So if x is greater than 50, or mouse x minus 25, so let's jump over to Illustrator to sort of make sense of that. So mouse x is here, right? And so it's mouse x minus the width, which is this value. So if it's greater than mouse x minus half the width, which would put us here, right? Or, sorry, and it's less than mouse x plus the pad width. So that means it's mouse x plus the pad width. So that means if it's between here and here, so it's met both of those conditions, and it's greater than y equals height minus 25. So if it's above here, if it meets all three of those conditions, then it bounces. Okay, so we change the direction of it. So move y goes from a positive to a negative, or a negative to a positive. It's always, move y is always going to be a positive when it hits, and it'll bounce. It'll return as a negative. And then these two conditionals are basically bouncing the ball off the side walls. So the one other piece is to take this and put it not just if it meets this condition, but also if I score a point. Because this program should acknowledge success as much as it does failure. And the other thing you could do is if it does score a point, you could take pity on me, if like when I was playing this the first time, and say, go back up to the variables, pad w. So we'll set this at 30 again, but we'll say pad w. Let's see. So score plus plus. So that's if it hits the paddle, but if it doesn't hit the paddle, we'll say pad w equals pad w plus 5. So if I miss, it'll increase the pad. And if I get really good, we'll go pad w equals pad w minus 1. Okay, so let's try that. So if I miss, it'll subtract a point, and it will add 5 pixels to the width of the paddle. If I score a point, meaning I bounce the ball off, it'll subtract 1 pixel from the pad to make it a little bit harder each time I hit it. So now let's try this. See how it goes. Oops, I already missed one. Not doing well. There we go. Oh, score's going up. That's good. Down. So I'm just going to miss a few so you can see how the paddle keeps getting bigger and bigger. Because we're not hard coding the value of the size of the paddle in the conditional, it is responsive to the position as you go. So there you go. So again, a simple little game here. Harder than it looks. And you can use the mouse. You could use keys if you wanted to. That's entirely up to you. Okay.